Hello dear student, this is Devansha from LG Institute of Engineering and Technology, and we are learning the subject Basic Electrical Engineering. So far we learn about unit number 1, 2 and 3. Now we'll start with the new chapter that we define as electrical machines. Now in electrical machines, these following topics we are going to learn. One of the topic is called three-phase induction motor. So today we are going to cover three-phase induction motor. Then we will discuss rotating magnetic field RMF. It is also a part of the three-phase induction motor. Then single-phase induction motor, DC machines and generators. So let us start first with the three-phase induction motor. We'll start with the introduction. So what do you mean by motor? So motor is nothing but it will convert electrical energy into a mechanical energy, which is then supplied to different types of load, right? So here around us we can see fan, then microwave, washing machine, lift, elevators. In all the appliances there is a motor. So nowadays motor is the basic requirement of all electrical appliances. So that's why here need to convert electrical energy into mechanical energy. So here the induction motors are motors which work on alternating voltage. So it will work on alternating voltage where we have to apply the alternate supply. Induction motors having two types. One type of induction motor is defined as a three-phase induction motor. Another type we define as a single-phase induction motor. So here, in three-phase induction motors are widely used in industrial applications mainly because of they have simple and rugged construction, low cost, high efficiency, self-starting torque and low maintenance. So it is widely used in industrial applications. We'll start with one of the part of three-phase induction motor where you can see this is the overall picture of three-phase induction motor. So this is a three-phase induction motor where it consists of two parts. One part we define as a stator, which is a static part, and another part we define as a rotor. So you can see this is a stator part, which is a fixed part, and this is a rotor. So likewise, if we first start and discuss about the construction of stator, how here we can make this stator. So it is a stationary part of the motor made up of silicon steel stamping like this way. So you can see here these are the silicon stamping where they are laminated to reduce the eddy current loss. Same way, this is the part of the stator, the outer part of the stator where inside it is a rotor. So this is a slotted part of a stator which is made up of the silicon steel, right? So we are talking here outer part of this motor. When complete stator is assembled, the slots are formed on the inner side of stator. So the slots may be open, closed or semi-open type. So here in three-phase windings are accommodated in all these slots. So here the windings are accommodated or wound over these slots, and it can have a star or delta connection. So three ends of this winding are brought to terminal box where the AC power is applied. So you can here see this is a AC box where the three-phase signal is applied. Now the another part of this induction motor is referred as a rotor, right, which is continuously rotating around this stator. So that's why this is defined as a rotor. Now there are two types of rotor. Here if we define, rotor is nothing but the rotating part of the motor. It is mounted on shaft which consists of hollow laminated core with slots on outer periphery. The winding placed in this slot is called rotor winding, maybe two types, squirrel cage type of rotor or a slip ring rotor or wound type of rotor. So you can see this is a squirrel cage type of rotor where all the slots are available here, all these conductors are available here, and this rotor is kept on a shaft. Same way here. So there are two types of rotor inside this three-phase induction motor. One rotor type is a squirrel cage type of rotor, and another is called slip ring or wound type of rotor. So based on this, now we can categorize this three-phase induction motor in two types. One type is called squirrel cage induction motor, and another type we define as a wound type or slip ring type induction motor. Now, if we first talk about the type of rotor which is called a squirrel cage. So you see this, the shape is itself a kind of squirrel, where there is a copper bars around it which is mounted on a metal ring, and this cores are also laminated. Inside there is a mild steel have been used, which is a laminated part, so that will also produce magnetic flux around it. So you can see this is the diagram of the squirrel cage rotor, where all the slots are available here. They are the same slots. This is a shaft, and these are the rotor bars. So these are the rotor bars here, right? So let us further discuss about the squirrel cage type of rotor. So this rotor consists of laminated core with skewed rotor slots. The rotor body is made up of silicon steel stamping, and the construction looks like cage of squirrel. Hence it is called squirrel cage rotor. So this rotor conductors are permanently short circuited. Therefore it is not possible to add external resistance in this rotor circuit. So these are the short circuited. So no external resistance can be accommodated here. Hence the slip rings and brush are not required here, and simple and economic in constructions. Now this requires a less maintenance. So this is one type of rotor which we define as a squirrel cage. Another type of rotor we define as a wound type rotor or slip ring type of rotor. So you can see the rest of the arrangement as the squirrel cage is same, but here we add the external resistances to control the speed of the rotor, in another sense to control the torque of the rotor. So this rotor is having a resistance starter, and which is mounted through, or which is fixed through this slip ring and brush. So here defined as a slip ring type of rotor. So this rotor is wound for a same number of poles as that of stator. The rotor is made up of laminations with slots on the outer periphery, in which three-phase rotor winding is placed. The three phases are connected in star internally. Remaining three phases are brought out and connected to slip ring mounted on a shaft. So this are mounted on a shaft here. So this three phase are connected with the slip rings. As a regular three-phase winding is used for rotor, this type of rotor is called face-wound rotor type, and it is also called slip ring type, or external resistance here is added or can be added. So these slip rings are made up of copper and phosphorus bronze, where running under normal condition these slip rings are short circuited. So here we externally apply the resistance, so by that way we can have control of torque for this slip ring induction motor. Now if we talk about the comparison of the slip ring motor and squirrel cage induction motor, then the another name of slip ring induction motor we define as a phase wound rotor, and this is a cage motor. Same way in terms of the construction. So slip ring motor is quite complicated in construction, while squirrel cage is a simple. Resistance can be added externally to the rotor. Here not possible to any type of resistance or external resistance. Starting torque is high, but for a squirrel cage it is a low. It is a low. Brushes are present in a slip ring, here absent in a squirrel cage. Maintenance is a frequent maintenance is required since in a squirrel cage very less maintenance is required. Here the copper loss is very high in a slip ring motor while very low in a squirrel cage motor. Efficiency is very low in a slip ring motor while high in a squirrel cage. Same way, it is possible to control the speed of slip ring motor while not possible to control the speed of the squirrel cage. Same way, the power factor is low in a slip ring motor while high in a squirrel cage motor. Cost is high in slip ring while very cheap in squirrel cage type of motor. Starting current is very low in a slip ring motor while starting current is high in a squirrel cage type of motor. Now, what are the uses where hoist, cranes, elevator, where high torque or high initial torque is required, where the slip ring motor is required, but in lathe machine, fan, blowers, then profiting machine, etc. Are the application of squirrel cage motor where the low torque is required. Right? So here we learn about the three-phase induction motor and the construction of three-phase induction motor, where we learn about the stator as well as rotor, and there are two types of rotor. One is called squirrel cage and another one is called slip ring or wound type. Thank you, dear student. If you have any doubt, please write in the comment box. Thank you very much.